have a look at this graph. So as I mentioned last time, when we have a graph, what is the most important thing?
Labeling on
Yeah, to read the labels, right? To read the label, because the label tell us what it is. Okay, this label tell us is speed and time, right? Okay, so now I want you guys to have a think. So let's start from the most simple one, most easy one. The most common thing we see is a stationary. I want you guys to have a think. So what do you think a stationary object is going to look like on a speed and time graph? Yeah, so it's speed, right? If it's stationary, how big is speed?
zero.
Speed is 0. If speed is 0, and this is 0 over here, so if it's a stationary, it has to be just a horizontal on the bottom. That's going to be my stationary. Does that make sense? Okay, see, so let's say here. Section A. Okay, so right here, yeah, you can copy this down into your notes. Okay, so the object is stationary. That is a little bit different from our distance time graph, right? Because distance time graph, I just draw a horizontal line anywhere. Then that's stationary. Say this, if I have distance and time, if I write something like this, that is also stationary. Because the distance not moving, distance at 10, you did not move at all, right? Or you can draw here, 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 whatever it is, as long as it's horizontal, and that's stationary. But this one is different. With speed and time, stationary has to be at the bottom, right? Okay, say if I have this. I have a section B. Well, let's have a look. What's happening at this section B now? Yeah, the speed is increasing. Originally it was 0, now the speed is getting bigger. So B is actually going to be acceleration, right? The speed is getting bigger. And what kind of acceleration? Constant acceleration. That's because the speed is increasing at a constant rate, right? Okay, say this section B. Is speed is increasing at a constant rate. So we say object has a constant acceleration. Okay, I can hear very loud music. Can you turn the music off? Okay, let's just focus for 20 minutes, and then I'll give you guys time to do work. Okay.
Yeah, outside.
Oh, it's from outside?
Yeah.
Oh, yeah. Okay. Okay. Okay, so after we've done this, just quickly remind you guys from last lesson, not last lesson, the lesson before, is we also say, well, first important thing, we look at what the label does. The second important thing is we look at a quantity we call gradient, right? And gradient shows us a trend. Well, let's have a look for this graph. What is the gradient going to be, okay? So let's say gradient. Again, for gradient, we use rise over run, right? Okay, so what is my rise? And I need to find what is my run. So what is rise? Rise over here is the change of speed, right? Okay, change of speed. And my run is the time taken, right? Change of speed divided by time. So then what is change of speed divided by time? So how fast speed is changing. So we have to define this thing, right? Okay, so we give the name, we call it acceleration. Okay, all right, so I write down the definition of acceleration. So what is acceleration? Acceleration is Basically, it's how fast speed is changing. Tell them to turn the music off. Okay, guys, could you turn the music off so we can hear you? Thanks. Okay, acceleration is how fast is speed changing. So we use this. Well, how do we measure how fast something is? We use a change of speed divided by time, right? Okay, so that is going to be my acceleration. That's the definition of acceleration. Does this make sense? Does it make sense?
Yes.
No, it doesn't make sense. Okay, so let's think of this situation. Okay, so I'll use some numbers as an example. Okay, say this. Acceleration, we have two. We can have one is called acceleration, and then the other one is called deceleration. Acceleration is positive, deceleration is negative. Now I'll use some example. Okay, say this. For acceleration, say I'm running right now, right? Originally my speed is 0, and then my speed is getting bigger and bigger. So say here, originally you were at 0, and now you're gonna be at 5 meters per second. You can see there is an acceleration to 5, right? So if you say this, if you have another object, right? Let's say we just draw it over here. If another object say this, it went to 2 meters per second for the same amount of time. So don't draw this. For the same amount of time, this one only went to 2 meters per second. So compare this B to this called this C. Which one is accelerating faster?
B.
B is accelerating faster, right? Because for the same amount of time, B went to 5 meters per second. So C only went to 2, right? So if you say this, you're betting on a horse. Okay? So the horse is riding. So which one would you bet your money on? Do you bet on B or A? You're gonna bet on B because B is accelerating faster, have a faster speed, so it should be able to get to the finish line faster. Does it make sense? Same with cars. If you say, well, which one is a really heavy truck and which one is gonna very sporty sedan car? So B is gonna be the fast car and C is gonna be the slow car, right? So that tells you the acceleration. Basically, it's how fast speed is increasing. So speed increase really fast or speed increase not so much. Does it make sense? So that is called the speed, how fast speed is changing, okay? Or there's another way, a proper way of saying it is called the rate of changing of speed. That's a proper scientific way. But what is the rate of change of speed? Just how fast speed is changing. Does it make sense? Mm-hmm. Okay, and I'll give you guys some more examples and we can see. Okay, all right. So now we know the gradient gives me the acceleration. If I look at the gradient, and gradient we have another name for it. Do you guys remember what is another name for gradient? Slope, right? Yeah. So which is the slope? All right, slope over here. If the slope is big, means acceleration is big. If slope is small, then acceleration is small. Does this make sense? Mm-hmm. Okay, say right now we have acceleration, right? Okay, so let's draw another one. Let's draw a section C. This section C, and I'm gonna give it a horizontal. So now, what's happening at section C? Yeah, is this stationary? From the previous one, that is stationary, right? If we have a distant time graph. But what would this one be? Yeah, the speed at 5 meters per second, did it change? No, it did not change, right? Okay, so for section B, I just want to write one more thing. We can say gradient is constant. Okay, so acceleration is constant. Because the gradient is acceleration. If gradient is constant, then acceleration will be constant. Does this make sense? Okay, let's have a look at section C. Section C, if we want to explain what it is, first we know it's going to be constant speed, right? There's two ways to explain it. One way of explaining it, you say this, well, speed is at 5 meters per second, not changing. So it's constant speed. Okay, so you're just cruising at a constant speed going forward. Okay, and then the next one is another way of explaining it is I can use my gradient, which is acceleration. If what happened to the gradient? How big is the gradient of C? Okay, can we put the computers away, please? Because we don't need to use the computer right now. Okay, so what is going to be the gradient of C? Horizontal line. From mass, gradient is 0, right? Okay, so let's say section C, another way of explaining it is this. I can say the gradient is 0. If gradient is 0, and then how big, what is going to be 0? Acceleration is going to be 0. Because gradient is acceleration, right? Okay, so acceleration is 0. If acceleration is 0, what tell you about the speed? It's going to be a constant speed, right? You're not changing your acceleration. You're not accelerating or decelerating, so it's going to be constant speed. Okay. Does this make sense?
Yes.
Okay, so now I'll give you guys another one. After you write this down. Okay, so I'm going to do another one, and I want to compare this one to a D. I want to compare this D to B. Say if D is going to be like this. Let's have a look at the D compared. First, we're going to figure out what is D.
Acceleration.
D is still going to be a constant acceleration, right? Because the gradient is the same. Well, that is because the gradient is constant. Constant gradient is constant acceleration. The gradient is acceleration. Okay, and then the next one is how big will B's acceleration be compared to D? D and B. Which one have a bigger acceleration?
B.
B. Why does B have a bigger acceleration? Yeah, because the gradient is bigger, right? So I'll say here, so D has a smaller gradient, and I can say slope. The slope is less steep slope, so D's acceleration is smaller than b. Can you guys see from the back? Can you guys see? Okay. Does this make sense? Okay, if I look at the number, I can see, well, that is pretty much the same amount of time it takes, okay? So this has rise from 0 to 5. Well, if we have a look at this number here, say that is about 6 meters per second. So for the same amount of time, you can see the time here, the time takes over here. This one B has increased 5. And this one only increased 1 meter per second. So you can see this acceleration is a bit smaller. Does that make sense? Okay, if you think about a car situation, this part is, boom, you put the pedal all the way to the bottom, ooh, you're accelerating, and then you hit a constant speed, and you want to go a little bit faster, you push it down again, and then you just go a little bit faster, but not as much compared to your acceleration over here. Okay? Okay, and then obviously you can have a constant speed going forward, and then with distance and time graph, we've learned that distance and time graph will never go downwards, right? That's because you can't redo your distance. You've already walked this way. Even if you walk backwards, you are still going to increase your distance, right? Okay, but for speed and time graph, we can have the thing go downwards. So now let's have a look. I'm going to give you an E section. Can you guys have a think? What is happening at this E section?
Speed's going down.
Constant deceleration.
Yeah, speed going down. If speed going down, it's going to be a deceleration, right? Yeah, and not only it's going to be a deceleration, it's going to be a constant deceleration. Okay. Okay, section E, going to be constant deceleration. And then if we have to give the reason, we will say the gradient is a negative value. So that is 0 gradient, that's a positive gradient. So if it's going downwards, that's 0, that's positive, and that's a negative gradient, right? Okay, because the gradient is negative, gradient is a constant negative value. So the object is the object's acceleration is a constant negative value. Does this make sense?
Yeah.
Okay, so this shows us so what is a speed and time graph going to look like, and what does that tell us about the motion? Okay, and obviously this line could be curving as well, but at the moment we don't need to talk about the curving one. We just need to know if it's a straight line one, okay, what does it mean? Here, stationary, here, constant acceleration, that is a constant speed, then constant acceleration again, and then a constant deceleration. Okay. All right, so that's all we need to do for